You're probably disappointed to see me up here. My colleague Priyanka Sharma is supposed to do this talk, and thanks to our fearless leader in America, Donald Trump, her visa stuff got all messed up, so she wasn't able to come at all, which is incredibly annoying. She got her everything set up properly. During the Obama administration, the thing she was trying to accomplish would have taken about a week or less, and it's been like over 2.5 months, and they just like anything relating to immigration, the Trump administration has just basically stopped doing. Lovely, it's lovely. Anyway, here I am. You're stuck with me. I work with Priyanka on OpenTracing. I'm one of the co-creators of the project. This particular session is meant to be an introduction to OpenTracing in general. It's a very short session. I wish it was longer. I think it's 35 minutes, is that right? So, I'll try to get through this stuff relatively quickly and leave time for questions. I think the ideal outcome for me is that people here who are interested in this will come up to me afterwards and say, hey, I'd like to talk more about this, and then I'll tell you, that's great, because I have nothing on my schedule for the rest of the day, and then we'll find a time and we can chat about stuff. Carlos, who also works a lot on OpenTracing, is up here, as well as a few other folks who are implanted around the room who know about this. Maybe people who know about OpenTracing and are experts, some of the eager folks, can come up here afterwards as well, and we can kind of divide and conquer. Is that cool, JP? I hope that transpires. Anyway, I have about 25 minutes of material here, which I'll go through, which again is an introduction to OpenTracing. On Friday, there's another session that's more of a slightly more intermediate advanced thing, but I'm not making any assumptions about anyone's knowledge around tracing in general, or OpenTracing in particular for this talk. So it's mostly focused on giving that kind of background. So the first part of the talk is why you should care about tracing at all, and to a certain extent what it is. So microservices, I think they're here to stay. My company actually published an actual research report today about this, but I think it's something like in companies where you have more than 500 engineers, something like 92% of them are incorporating microservices right now, and the year-over-year growth is quite high. There are 98% of people adopting microservices are having difficulty with root cause analysis, and that's because the move to microservices broke your monitoring stack to a certain extent. If this is your monolith, and within your monolith you have a bunch of package boundaries, the packages roughly turn into services. Of course, this is all slide level correctness. I know it's not quite that simple. You had a transaction, and I use that word in the most general sense, that just something happened, a request came in, and the request of the transaction would go through your service and touch all these different packages. That still happens in a microservices architecture, except now that request is propagating not just across package boundaries and function call boundaries, but across services. So you need to tell that story somehow. If you can't tell that story, it's almost impossible to understand, even at a very basic level, what's taking place within an application that incorporates microservices. I hope that makes sense, but it's a fundamental thing. This isn't about P99.9 latency. This is just about, I'm using microservices and I want to understand, even to a first approximation, what's happening in my production system. So that's this problem. Another issue about systems these days, it related to the microservices, but not caused by them. There's a move towards higher concurrency and parallelism. And in my brain, I often think about transactions as just happening one after another. Of course, I know that actually they're happening at the same time. They often involve callbacks and closures, especially in Node or JVM, places where you'll often enqueue things in a separate executor to run later. And it's even worse than this because the asynchrony is happening now across many different services. So individual requests are stopping and starting and happening concurrently in many processes. And somehow you need to go through that and isolate a single transaction or a single request as it propagates across your system and make sure it doesn't get confused by all of the noise coming from other requests. So it's not sufficient just to record everything and piece it together later. You need to record everything and keep track of which request is which. So distributed tracing is about this. It's the answer here. You consider all requests and all services. You connect the dots between the services as requests propagate from one process to another. And then you present the traces that matter back to the end user of a system. I went through that fairly quickly, kind of rough consensus that made sense. Okay, I see some nodding, hopefully mostly vertical nodding, not horizontal nodding. Cool. This is just to make sure this really comes through. On the left, we have a structural diagram, like the type of thing we put on the whiteboard, of a client talking to a server that then talks to auth billing in a database. Tracing systems typically represent this as a timing diagram instead of a a schematic diagram, mainly because there's so much concurrency in these distributed systems that it's very difficult to understand what's actually happening when if you do it this way. Through my job at LightStep, we see a lot of production systems that have hundreds of microservices, and it's not uncommon for there to be literally thousands of these little boxes in a single request from an end user before it goes back to the user. And so if you represent that in one of these diagrams, although it's very impressive and kind of fun to look at, it's almost impossible to understand. And so you end up representing things in a timing diagram with the capacity to expand and collapse individual branches of these things. So if you see screenshots from, Zipkin or Jaeger or whatever your favorite distributed tracing system is, it'll often be of this view. This is the thing that is the closest we get to understanding how a single request propagates across a system. All right. I wrote this slide for a different talk, but I kind of like it, so I put it in here too. I thought it might be useful to talk about how tracing fits into the larger spectrum of tooling that we use for monitoring and observability. I think the party line for cloud native computing is that you have metrics, logging, and tracing. Since I'm the one who's up here today, I'm going to say I don't really buy that. I don't like that at all. I think it's actually very misleading. I think that those are three technologies and not three use cases, and logging and tracing, I think, are very closely related in that they're both event monitoring. The way I tend to think of this myself is that these columns here are the two broad types of data we have, and these rows are the two broad use cases we have. The two broad use cases are to measure symptoms that matter to our businesses. So typically that will be things like the P99 latency for my service should never go above 500 milliseconds. Or another example would be the error ratio. The ratio of error, the ratio of the total number of errors per second to the total number of requests should never be higher than 0.1%. Those are symptoms that matter to you. And again, there usually aren't that many symptoms that matter, but they matter a lot. And then the rest of the work is about explaining those symptoms when they aren't looking the way we want them to, or debugging systems when they're not behaving the way we expect them to. And the type of use cases for tools are quite different in the measuring of symptoms and the explaining of symptoms. Tracing can be applied in different places, but usually distributed tracing is down here in the bottom right. It's definitely structured data. As I said, it's I think, structurally very similar to logging data. It's usually a higher volume than logging data, but there's no reason that you couldn't log at a high volume. The thing that sets it apart is that you have both the timestamps and the structure of logs along with causality information. So you don't usually know in a logging system which log line caused which other log line. In a tracing system, you do know that, and that information is essential to the presentation of the data and how it's interpreted by end users. So I tend to think of tracing and logging as being on a continuum over here in the structured events column, and metrics and certain types of error monitoring and things like that where they get aggregated into statistics are over here in this column. So I think of this as the squiggly line column, and this is the telling stories through actual transactions column. I hope this is sort of interesting to people as a way of thinking about this stuff, but it's definitely the way that I internally think about it. And metrics, logging, and tracing are in different places here, but those aren't use cases, those are just technologies. So, all right. So why isn't tracing ubiquitous if it's so handy? That's the big question. And I was at a workshop. Actually, this is when OpenTracing was really created. I was at a workshop with a bunch of people who do tracing full time. Some of them were people who were working on Zipkin or Jaeger. Some of them were people who worked at big technology companies that were moving to distributed tracing, and they sent people to the workshop just to exchange stories. And the official proceedings of the workshop were a bunch of presentations where people showed their UIs to each other, and we talked about all of the cool analytical features. And then all of the lunches and dinners and drinks were people just commiserating about the fact that the analytical UIs weren't really working that well because all the data coming in was garbage. And that's typically the problem that people were facing a couple of years ago, where you wanted to adopt tracing and you knew it was a good idea. By the way, there are a bunch of seats up front if people want to do that. The trouble with tracing was that instrumentation was too hard, like really, really hard. You'd have someone who is the tracing champion at a company just going from group to group and essentially begging them to instrument their code, which they didn't do. And so there was no data, and then there's a cycle there. And with no data, you can't show the value and so on and so forth. And I don't know, actually, this is an interesting show of hands. How many people here at companies that are actively using some sort of distributed tracing? It doesn't have to be OpenTracing. And how many people are trying to get that rolled out? How many people would say that it's like a big success and everything is integrated? Right. Okay, there's a couple. That's about right. I do see it happen sometimes. It's really difficult to do. It's very difficult to do. And I would contend that the thing that's preventing adoption more than anything else is that the data quality is not there, which is basically an instrumentation problem. There are efforts to do this automatically through software agents and things like that. I'm a bit skeptical about that. We definitely tried to do that at Google, and it was just infeasible. And that was actually a much more controlled environment than most companies have, in that we didn't use as much open source stuff, and we built a lot of it internally. But instrumentation has been really, really difficult. So the idea with OpenTracing is to solve that specific problem. I think there has been a lot of confusion in the tracing world, and I gave a talk earlier today about the tracing space, which was recorded, and I would encourage people to at least look at the slides. OpenTracing is designed for this one problem, which is instrumentation. The problems we're trying to solve, you shouldn't get locked into anything, whether it's a particular tracing project or a vendor like my company. I don't want anyone being locked into that vendor at the instrumentation level. That's not a good idea. You shouldn't have to monkey patch the code. It's extremely difficult to maintain that at scale. I was just talking to someone at lunch about this, that even if the public API doesn't change, if you're going to monkey patch a communication library, if they make a minor version change and just refactor their code, that breaks their instrumentation. And there are many, many, many minor versions, and you need to maintain against all of them. It's way harder than instrumenting the code because it's not part of the compilation unit, and it breaks so easily. So you can't monkey patch things, at least not at scale. The APIs from one language to another have often diverged for different tracing systems, and that creates a lot of semantic confusion because you do need to propagate across boundaries. And then perhaps more importantly, within a single process, if function A calls function B, but they're in different libraries, the tracing needs to propagate across those boundaries, even if it's going across threads. And that requires a certain, it's not like, what would be a good example? There are other situations where different libraries can choose to do things in different ways, and that's just fine. But if you want to have a single trace that's uniform across the entire call stack, which is a requirement, you need to have a common library. So it doesn't work for everyone to instrument distributed tracing separately. They need to use the same instrumentation strategy, and that requires some level of coordination and standardization. So this is what OpenTracing is all about. I was saying this earlier. This is not meant to be a scientific slide. I didn't actually measure how many pixels wide the green and the blue are, but the spirit of it is that the pain of instrumentation is dominated. The pain of adopting tracing is dominated by the logic around either per service, business logic, or third-party open source that you bring in, and the pain around the UIs and the backends and the SDKs and things like that are minimal by comparison. And OpenTracing is an attempt to address that problem. It's designed for people who develop systems that are, quote unquote, cloud native. I know that means different things to different people, but let's say if you're developing many services in your application, it should apply to you. It's also designed for people who develop open source packages. OpenTracing is now supported by over 100 open source packages, and in some cases is built in natively, like Couchbase recently added OpenTracing to their actual code. It's not like a plugin, but if you depend on Couchbase, then Couchbase has hooks for OpenTracing built into it, and so does CockroachDB and a few other things that are more kind of modern database data stores. The idea there is that if you depend on Couchbase, you don't just know if a call is slow, but you actually get to trace all the way through into Couchbase's internal systems just by virtue of using it. And that's a very powerful vision. And we had something like that at Google, and it was really nice. Like, you'd understand it wasn't that Bigtable sucked. It was that your query was forcing Bigtable to read from disk on 45 machines at the same time. And a trace would show that to you. And instead of just getting frustrated, you could actually visualize why your requests are so expensive. So I think there's a lot of power in getting tracing built into the things we depend on. Again, so it's not just about your company's code, it's about the code you depend on, both in managed services and in shared libraries that you link in. And then, yeah, people who develop monitoring systems, whether they be actual tracing systems or like Adit Levine built this thing called Squash, which is a distributed debugger that uses OpenTracing as the hooks for all of the debugging stop points. So you can build things out of this instrumentation beyond just a tracing system. You can use instrumentation to do lots of other things as well. This is the mental model of OpenTracing. I was looking at the time here, pretty good. So we have a bunch of terminology that is mostly borrowed from Dapper, which is a project I worked on at Google to do distributed tracing in that company. You've got the trace itself is composed of what we call spans. A span is something that has a start time and an end time, and it describes a single unit of work. That's very vague. I mean, obviously that could apply to like a single instruction in a CPU has a start time and an end time. It's usually things that are roughly the granularity of like a function, not a function call, but an RPC call or something like that. Maybe a little finer than that. I would say if the span is less than a millisecond, it's probably not the right level of detail. If it's more than a minute, it's also probably not the right level of detail. Something in that spectrum are things that are appropriate for spans. So yeah, inter-process communication, major subunits of work that have syscalls in them or have a lot of variability in their performance, those are good. Each span is allowed to have key value tags that are used within tracing systems and analytical tools to help understand the patterns in the data. And there's also a thing called a log in the OpenTracing vocabulary. It's not the same thing as the logs that you would send to Elk or something like that. It might be better called like a microlog. Each span has its own little tiny log that's attached to it where you can record extremely high fidelity data describing particularly what happened during the lifetime of that span. So for instance, for a database call, the log might log like when, for that span representing the call, when the query actually got fully sent over the wire, when the first byte came back from the database, maybe log the certain number of rows that come back, and then log once more when the whole thing is done. It's a way of telling detailed stories about what happens during the life of a span. So the final concept is this idea of a span context. This is a very small data structure that's sent between processes when you're trying to propagate a span from one service to another. And it's abstracted so that OpenTracing can support many different tracing systems without understanding what's in that context. To OpenTracing, it's just this blob that gets propagated around, and then the tracing systems that bind to OpenTracing can do whatever they want with that blob. This is a powerful concept in that it allows you to write code in OpenTracing that will serialize and deserialize to HTTP headers or other network protocols without understanding the details of how a particular tracing system does that. And this abstraction, it's what makes OpenTracing tick from inter-process communication standpoint. So these are all the concepts. The slides for this are going to be attached to the event in in the KubeCon schedule, and you're welcome to look at this. And this would be a great thing to ask questions about later, but I don't want to get way down into the weeds, given how short this presentation is. The architecture of the project is pretty simple. There's an API that's deliberately very narrow and limited. I think it benefits from a small scope. And then there are a bunch of things on the left and a bunch of things on the right. On the left, you have a variety of things, like everything from normal business logic to frameworks and existing instrumentation, kind of you name it. They call the OpenTracing API to create spans, propagate spans, tag spans, that sort of thing. And then on the other side, just once per process, OpenTracing is bound to some sort of backend, whether it be an open source solution or a commercial solution. This isn't necessarily done in the code. Like in Java, this can be done via class loaders and things like that. But the idea is that once per process, you bind OpenTracing to some kind of downstream system, and then all of the various application code that's linked into that service can use OpenTracing to describe the work that's happening within it. Hope that makes sense. But this is an important slide to understand. What this is not showing you, for instance, OpenTracing is not a tracing system. You don't run OpenTracing and look at the OpenTracing UI. It's just a project that is designed to solve the instrumentation problem and to make it less burdensome for developers. If you want to actually look at traces, you should use Jaeger or Zipkin or whatever, or if you want to pay my company money, you can use LightStep. It's great, but you should think of OpenTracing as a way to minimize the cost of onboarding into tracing. That's what it's for. It's about 2 years old. This baby picture is out of date. This is a 1-year-old baby picture, and I changed the slide to be 2 years old, but I didn't get a 2-year-old in the picture, but I'll work on that. I have to go home and fix that slide. So the project's 2 years old. This is actually pretty out of date. OpenTracing has been quite widely adopted. I think the downside is very small for people. You end up adopting something that doesn't slow you down and gives you a lot more optionality. In that, if you decide to switch tracing systems, that's fine. You get to hit the ground running with a bunch of support for things you already use, like Spring, or if you're in Go, a lot of the Go standard libraries are supported by OpenTracing. It doesn't have a lot of downsides, so it's been pretty widely adopted. Again, it doesn't solve the whole problem of tracing. You still need to send the data somewhere and things like that. So OpenTracing you can think of as a boon to your integration efforts and to bootstrap those. It's not something that will get you all the way. You do need to send the data somewhere as well. This is not a complete list, but there are a lot of projects now that support OpenTracing from an instrumentation standpoint. There are a lot of places you can send the data, and I think there are 9 languages that are formally supported right now, with another couple that are in progress. It's an interesting project from an open source standpoint. I've worked on other open source things in the past, and nothing's been quite like this in that it's sort of like a mile wide and an inch deep. I mean, a lot of the instrumentations for these things are very minimal and simple, but there's just so many of them. And so we have this community of people in OpenTracing that are responsible for just keeping track of these things. And it's almost as much of a registry as anything else from an open source governance standpoint. And it's not like there's a lot of deep IP in these things. It's pretty straightforward code, but by writing it once and doing it for everyone, then it doesn't need to get written again. So I really like when people contribute. Often packages that take a couple of days can have a lot of impact in OpenTracing. So if people here like this stuff and you want to get involved, just let me know, and I can show you what the hit list is right now for things we want to add to OpenTracing in the future. But it's an interesting project. The work that goes into the actual language APIs is done with a lot of care, and there are processes around how that works. The work to support the hundreds of different projects, depending on the project, can be very easy. It can kind of a weekend project, or sometimes it involves a lot more heavy lifting, but it's usually pretty fun and interesting. And I like the idea of the instrumentation becoming part of the code base. Kind of like unit tests used to be something that were done separately, and now we all just take it for granted that the unit test is part of the code and it's part of your code base. That's how I think of this instrumentation. And the newer instrumentations we're seeing, it's not like some kind of plugin. It's that OpenTracing is actually built into the project itself. And I like that direction a lot. I think it will allow us to move a lot faster from an observability standpoint. So this is my list of ways to get started, and I did a pretty good job keeping this quick. So we'll have 10 minutes for questions, and and things like that. So there's a bunch of stuff in OpenTracing.io's Getting Started area. JP did an awesome thing in Katacoda. If you haven't seen that, it's kind of this cool thing where it loads up Docker containers for you and lets you experiment with code. There's some stuff there already for running Jaeger and OpenTracing side by side. And JP has done some stuff around actual instrumentation that you can tinker with, and you don't have to download a bunch of packages onto your computer. You can just play with them. And there's a lot of open source instrumentation that's in the OpenTracing contrib organization. OpenTracing is split into an OpenTracing organization and a contrib organization. The latter has all of these integrations with various things, and you can read that to get a sense of how this stuff looks and feels. If you want to understand the historical context, the Dapper paper, which I wrote with some folks at Google, has a lot of the same concepts. And if you're having trouble falling asleep, it can be an effective sleep aid as well. There's a better paper that isn't as well known, but I'm trying to fix that I did not write, Pivot Tracing, which is actually an excellent paper that talks a lot about what you can do with tracing beyond just timing diagrams. It's really powerful, actually. A cool paper. I highly recommend reading that too. And if you want to start instrumenting your own stuff, I think Jaeger is fantastic. It's also OpenTracing native and part of the CNCF for what it's worth, and is a great way to just get started with this stuff and tinker without much friction. And there's a really nice, friendly community on Gitter of people who will help you if you get stuck or have questions and things like that. That was my last slide. I tried to get through a bunch of material at a very high level, and I didn't pause for questions so that we could get to this point. But we have 9 minutes, and I'm happy just to field questions. And if people want to, contribute stuff, that's great. Go for it.
What's your take on OpenCensus?
The question, I'm supposed to repeat the questions, is what's my take on OpenCensus? It's a good question. I mean, OpenCensus, for those who aren't familiar with it, is essentially an open source version of Google's internal tracing runtime. So the scope for OpenTracing and OpenCensus is partially overlapping, but not completely overlapping. OpenCensus both has an instrumentation API as well as an implementation of that API that are relatively tightly coupled. And I think in some languages you can't really have one without the other. I could be wrong about that. I think that's how it works in Java. The advantage to doing that is that as kind of a framework approach, they're able to not just have the instrumentation, but it actually generates data and will send it somewhere for you, which I think does have some real advantages. The risk with OpenCensus, I think, at some level is that by coupling those things together, it does introduce some dependencies into the code base. Like if you bring in OpenCensus, you bring in dependencies on their particular netty thing they're using to export the data and so on and so forth. And then I think also it does make a bunch of assumptions that you want a model, kind of like a Dapper-like model. I think that there are nice applications of OpenTracing, like the distributed debugger I mentioned earlier, that wouldn't work in that model. So I'm of the opinion that it's good for these. I think OpenCensus is excellent code. I would like to see the projects fused, frankly. I'd like to see OpenCensus and OpenTracing be the same thing. I've told them that many times. I don't know if they're going to do it, but I'd like them to share literally the same code as the API, and then have OpenCensus be the world's best Dapper-like implementation. I will just say kind of briefly, I'm trying to be cautious about this. I don't want to seem like I'm being catty, but there's a storyline about Google projects being open sourced and how that's good. Google is it's not good to copy Google's technology necessarily. Google's technology is built for Google scale. They're doing the published number, which is not the real number, by the way. It's much lower than real number, is that they're doing 2 billion RPCs per second at Google, which is a lot. There's always a tension between the scale of a system and the functionality. And so if you're going to support 2 billion RPCs per second, the systems that you build must have fewer features because there's just a natural tension there. And I do think it makes me nervous when we take things from Google and assume that they're going to be better because they came from Google. They're good if you run that kind of scale. If you don't, they might actually be inappropriate. And I think that there's some of the design decisions that are made in some of these runtime libraries are very appropriate for extreme scale, but if you're running at an even sort of normal scale, they limit the features as a result. So I like the idea of decoupling the API from implementation, because the instrumentation doesn't change at scale, but the kind of API, the kind of implementation you want does change. So I feel very strongly, I mean, OpenCensus is great, but OpenCensus should separate their API and that implementation into two separate things, so that depending on your scale, you can choose a different set of features. That's the only thing I really feel strongly about, but it's a very nice piece of code for sure. And I like the people involved for sure as well. So.
Did you look at application response measurement when you started OpenTracing?
Do you mean, did I look at application response measurement when I started OpenTracing?
Stand up like 15 or 20 years ago, which is now hosted by the Open Group, I think, which does more or less the same thing.
Yes, I am familiar with it. The trouble that we were faced with at the time was being that being what it is from an age standpoint, making changes to it were sort of, it seemed almost impossible to make changes quickly, and a lot of the languages that were needed by the people working in OpenTracing weren't like naturally supported by that, and so we didn't pursue it very far. In retrospect, it might have been good to have done that. I'm not saying that was the right thing, but that's what happened. Yeah, but there's a historical precedent for almost all of this stuff. Like tracing itself feels like a very new thing, but of course people were doing it with supercomputers in the 80s. It's the same thing, a different name, same thing. Yeah, maybe not the best answer, but.
You might have teams pushing for what they call debug logging. Do you think with appropriate instrumentation from a tracing perspective, it would be able to so far?
So the question is, a team is pushing for debug logging in production, I assume, or
No,
in dev?
integration.
Okay, so debug logging in integration environments, would tracing obviate the need for that? I think there's two kind of categories of logging that I've seen. There's logging that's more about the lifetime of the process, like the process crashes or something like that, or the process is starting up. That's not about a particular request in the system. That stuff doesn't fit very well with tracing, because tracing is about request tracing. However, if the debug logging is about requests, like absolutely, definitely, I think it's better to replace the debug logging, because, well, unless the debug logging supports correlation across process boundaries, in which case it is distributed tracing. So, but I think like doing single service logging in a microservices environment is of very limited value, because even if you find something interesting, you can't contextualize it. So I think it makes a lot of sense to use tracing for request-scoped debug logging. And in fact, I think those are almost the same thing. My last comment there is that because tracing systems typically support some kind of sampling, you can then run that same logging in production continuously, which I think is a nice side benefit. Or with logging systems, that tends to be too expensive because there's so much data.
Does it work with the service mesh?
OpenTracing or tracing? Does OpenTracing work with Service Mesh, Istio, and Envoy and stuff? That's a great question, sort of. So there's, let me go back to this diagram. Yeah, so to take this diagram, I did a keynote at KubeCon in Austin in December that was literally about this topic, which is going to be better than the version I'm going to do here. But it's possible to record these two arrows, and these two arrows, and these two arrows, and these two arrows. You can get that. And that's actually really valuable, because those network calls are super, super important. The thing that doesn't cover is that if you can't actually say that this arrow led to that arrow, none of it's that valuable. So I would say it's necessary but not sufficient. If you're using Service Mesh, the Service Mesh can generate a lot of interesting span data, but you still need to connect the ingress to the egress in every service, right? So if the request comes in via Service Mesh, then a bunch of stuff happens and you hand from thread to thread, and then you make a request out through Service Mesh. All that crazy jumble in the middle, you need to keep track of that too, and the Service Mesh won't help you with that. So I think it's a great integration point and a valuable one, and OpenTracing is actually built into Envoy, and I believe if it's not into Istio yet, I know there's an open PR about that. It is? Okay, cool. So yeah, it's supported in the service mesh, and I think that's wonderful, and everyone should use it. It's not going to solve your problem. Like, you're still going to need to have the actual services instrumented too, unless they do truly trivial things. So they take a request, they never switch threads, and they make a request. If they do that, then it will just work. But if the services have real internal complexity, you still need to instrument them as well, or the distributed trace will be disconnected. Does that make sense? But it's a good question. I think service mesh sometimes overpromises on the tracing front. It's not enough just to do service mesh and then you'll get distributed tracing for free. There's still pieces that are missing. Support in OpenTracing for really old languages like COBOL, that sort of thing, for example. I mean, no one's stopping anyone from doing it. I think the issue is that typically in those environments, the code itself that's been written is in a almost read-only state. And so even if you had OpenTracing, the instrumentation piece can be really daunting. So I have seen some efforts to do things like that, and I'm very supportive of them. I think it's awesome, actually. But it needs to be an environment where the old code is not pure legacy code. Like, it still needs to be edited, or the instrumentation won't be of any value, or you won't be able to get it in there, if that makes sense. But it's certainly nothing. The concepts in OpenTracing port naturally to any language. It's not that complicated. Yep.
But it seems like that's very system specific, that Jaeger attempts to sort of like try and find some sort of framework to say that this trace is really want to do that.
Yeah.
What are some of the efforts like within the tracing team? Are there any efforts to sort of like understanding of how to say that this trace is really important and actually
Yeah, so summary of the question, this will be the last question. That's part of the thing, so I'm out of time, I think. But I'm happy to, I would again encourage, where did JP go? Maybe he's gone, I don't know. Well, oh, got it, makes sense. Well, after this, please come up and Carlos and I can help answer questions too. About sampling, the question was, is there an effort to standardize not just like how you give hints to the tracing system about sampling, and to say this is important, this one's really, really important, I really want you to sample it. We've talked about it a bunch of times. It reminds me a little bit of log levels. It's a very similar problem where, we've all been there, right? It's like you've tried to be consistent about what fine, finer, and finest actually mean, but it doesn't really work. I don't think there's like a super clean solution. Like for code that one person is writing, maybe you can get the relative priorities right, but it's hard to do in a general way. LightStep's take on this is a bit different, which is just record all of it and then figure out importance in retrospect, because a lot of times the importance of something is only visible after it's finished. That's a very different approach to trying to get it into the code, but I do kind of like it. I think it's really hard to predict how interesting something is going to be even while it's happening. You sometimes need to wait until it's over to know if it's important. But anyway, long story short, yes, there's like a sampling priority tag in OpenTracing, but it's not widely respected in a consistent way by implementation, so it's of limited use. There's a W3C effort to standardize this stuff more, and it also they just gave up on figuring out sampling semantics, so I'm not optimistic, to be honest. Anyway, I'll make that the end. Thank you all for your time. Please come up if you have questions. Thanks.